Good morning, students. I am going to discuss about ionic equilibrium. That is, ionic equilibrium is a special kind of equilibrium that deals with the equilibrium of weak electrolyte like acetic acid or weak base like ammonium hydroxide in aqueous solution, so as to find out the relation between Ka or Kb with respect to alpha, the degree of its dissociation. And Oswald dilution law is used to study the ionic equilibrium of the weak electrolyte generally to find out this relation with this Ka or Kb with respect to their alpha. Okay, now we have to derive the Oswald dilution law, the expression for Oswald dilution law, so as to find out the relation between Ka for weak acid or Kb for weak base with respect to alpha, the degree of dissociation. Let us consider the case of a weak acid like acetic acid as a typical example. We have C moles per liter of acetic acid in the aqueous system, so that before equilibrium we have 0 concentration of acetate ion and 0 concentration of H3O plus ion. At equilibrium, okay, after dissociation, what is actually happening is that a small amount of acetic acid is a weak electrolyte. A small amount of acetic acid undergo ionization or dissociation in water to give a small amount of acetate ion and hydronium ion. That is, a dissociation equilibrium or the ionization equilibrium consists of acetate ion and hydronium ion as a dissociated ion and undissociated acetic acid molecule at the equilibrium. So, when we look in the equilibrium, there is a steady or constant concentration of acetate ion, hydronium ion and unionized acetic acid molecule. Applying low mass action to this ionic equilibrium, we have the dissociation, that is ionization constant K is equal to the concentration of acetate ion at equilibrium and the concentration of hydronium ion at equilibrium divided by the concentration of unionized acetic acid molecule at equilibrium into concentration of water. Okay. Suppose alpha is the degree of dissociation of acetic acid, that I have already mentioned. Alpha is the degree of dissociation of acetic acid. Then we have at equilibrium C alpha moles of acetate ion and C alpha moles of hydronium ion and C into 1 minus alpha mole of undissociated acetic acid. And therefore you have to remember the concentration of water is a constant because it is present in excess amount. So we can rearrange the equation, that is K into H2 now become equal to Ka, the dissociation constant of the acid. Now the ionization equilibrium is known as the dissociation constant or the ionization constant of the acid, that is K, that is equal to the concentration of CH3CO minus into concentration of H3O plus divided by the concentration of undissociated acetic acid. That is, now substituting the value, the various concentration factors in the equilibrium, now Ka is equal to, that is concentration acetate ion, that is Ca, into concentration of hydronium, that is also Ca, divided by the concentration of undissociated acetic gas, that is C into 1 minus alpha. That is come to be C alpha square by 1 minus alpha. Okay. Since alpha, the degree of dissociation of the weak acid is extremely small quantity and is very much less than 1 for a weak electrolyte, it can be neglected in the denominator compared to unity. Therefore, the dissociation constant of the weak acid Ka now become equal to C into alpha square. C into alpha square. Since the concentration C is inversely proportional to volume, or C is equal to 1 by V, then we have Ka is equal to alpha square by V. Okay. Therefore, the alpha, the degree of dissociation is equal to square root of Ka by C, or alpha is equal to square root of Ka into V. Thus, we have two relation of alpha through Ka. Okay. Through Ka, one is inversely proportional to C and other is directly proportional to V. Similarly, for a weak base, alpha is equal to square root of Kb by C, or alpha is equal to square root of Kb into V. This equation are generally known as Oswald dilution law for weak electrolyte, that is for weak acid and weak base respectively. That is, the significance of the law is that, why it is called dilution law is that, alpha is now directly proportional to the volume V, or the extent of the dilution, or inversely proportional to the concentration of the solution. That is why this equation is called dilution law, as cited by Oswald. So, we have the relation, that is alpha is equal to square root of Ka by C for weak acid, or alpha is equal to square root of Kb by C for weak base. Okay. And you look at the equation, the concentration of H plus ion or hydronium ion, the case of a weak acid is C alpha. It is equal to C alpha. It is something different from our strong acid. Okay. The concentration of the hydronium ion present in the aqueous solution of the weak acid is not the initial concentration of the acid, but it is C alpha. It depends on the degree of dissociation into its initial concentration, because it is weakly ionized. Therefore, at equilibrium, the concentration of the H plus ion is equal to C alpha. That is very important. The concentration of H plus ion present in the aqueous solution of weak acid is equal to its initial concentration into degree of dissociation. Okay. Therefore, we can have if we have two different acids, our dissociation constant Ka1 and Ka2 with their degree of dissociation alpha 1 and alpha 2. We can very well compare the strength of the acid 1 with the strength of the acid 2. That is, we have the relation or the relative strength of the acid. That is, strength of the acid 1 by strength of the acid 2 is equal to alpha 1 by alpha 2. That is equal to square root of Ka1 by Ka2 for a given concentration C of the two acid. That means, for a given concentration, we have alpha 1 by alpha 2 is equal to square root of Ka1 by K2 give the strength of the acid 1 by strength of the acid 2. Okay. So similarly, for the case of a weak base also, the equation remain the same. That is strength of weak base. Okay, strength of base 1 by strength of base 2. Base 2 is equal to alpha 1 by alpha 2. Now comes to be equal to k square root of kb1 by kb2. That's okay. So you please try to work out some problem using the textbook so as to they are using this also dilution law so as to calculate alpha. Okay. Or calculate K or calculate H plus provided C is given. Thank you very much.